heat transfer. The transfer of heat takes place by three different approaches: conduction, convection, and radiation. All the three processes have their own definitions and characteristics. You see, conduction means possible in all solid, liquid, and gases, but you could say that the degree wise, this is maximum in solid, then in liquid, and then in gases. You could say the thermal conductivity is maximum for solids, then for liquids, then for gases. And in solids also, if you compare, you'll find the conductivity is maximum for silver, then copper, then aluminum, then iron. It goes on. There is a wide range of elements having a descending conductivity. Now, what is conduction? Conduction means the molecule is taking part. The interaction of molecules or the atom, that is responsible for the process of conduction. This is one atom. The heat is given from one particular end. This molecule receives the heat and its velocity or the vibration will increase. Means the vibration would be of higher amplitude, energy will increase. This energetic molecule will collide with the neighboring one and will transfer its energy, and this is the process that continues till the end. That means it is because of the molecular interaction. One by one, every part of the atom or the solid is taking place, and the heat is getting transferred from one end to another. Here, the whole solid, whole bulk, whole material has taken part in the process. Conduction, then convection. Convection process is basically for fluids, but fluid means, that can flow, that is liquid and gases. Convection takes place in both liquids and gases. We could say that this process could be more better defined in the case of liquids, but equally it takes place in case of gases also. And there also, when we follow the process of convection, we'll see the material takes part there. In radiation, there is no effective role of the material, or there is no role or significance of the molecular interaction in the process of radiation. Now, let's define heat conduction in detail. Suppose you are having a piece of metal, two ends having temperature, just say theta 1, theta 2. You see, the entire chapter of this conduction that we will study and all the relations will be applied to a steady state. You might ask me, what is a steady state? Whenever we supply the heat to a material, initially there is variable state, and then ultimately it becomes a steady. Variable state means every part of the material is absorbing heat and heat is getting transferred as well. But in a steady state, there is no part of the material that will absorb the heat. In a steady state, the absorption of heat is totally stopped and there is no increase in any part of the temperature. There might be difference in temperature at various points, but every part will be having temperature constant with respect to time. That is what we exactly call a steady state. So, this is automatically understood. Whenever we define any kind of relation like this is going to be applicable for a steady state only. You see, in this relation, Q equal to Ka delta theta T upon D. D or L you might use for length. This whole part is length of the conductor. A is going to be the cross-sectional area through which the heat is entering and it will go away. Then K is known as thermal conductivity, or you might say coefficient of thermal conductivity. It is analogous to a specific electrical conductivity that's used by letter sigma while studying electrodynamics. Then T is the time, Q is the amount of heat flown. This is the relation that we might use, or we might compare with the relation eta A dV dx. You know this eta, this thermal conductivity, and sigma in electricity, all three are analogous and are known as transport phenomena. But we have to focus on this relation only. Here delta theta stands for temperature difference between the two ends, that you might say theta 1 minus theta 2. Here you have to remember one very important thing, that if you say the heat Q is entering from one end, it is understood that the same amount of heat will enter in the same time, in equal time. Equal amount of heat will enter through this end and it will go out from this end. This is what we exactly mean by steady state. This relation is applicable for steady state only.